Okay, so now that we have concluded the story on struct union, const, and volatile, the other two important topics are that of bit manipulation and pointers. Now, what we're going to do is just let you know of the important things to remember in bit manipulation and pointers. And for both, we have like separate dedicated resources, a course or a playlist that is available for both of these. And the details can be found there. But the things that you should keep in mind, let's start with bit manipulation first, is you have only ability to do ANDing, ORing, XORing, and inverting or NOT, the NOT operation. So these are the operations that we have when we talk about bit manipulation. And then the symbols are, well, and this vertical line for OR, the caret symbol for XOR, well, the exclamation mark for NOT or inversion, and the tilde if you want to perform the inversion on all the bits of a byte. Oh, okay, we'll come back to this in a bit. But Mohammed, do you want to add anything to the bit manipulation part?
Maybe the shift operations, the shift
Yes.
operators.
Yes. So there is left shift, and then there is right. Oh, sorry, got this other way around. There is right shift, and then there is left shift. There is something special about the right shift, and again, that is something which is covered in detail in the playlist on bit manipulation. Um, but first, let's talk about these two. So this essentially, this operator, if you have a variable on the right of it, it will just kind of invert the notion. So if this was a non-zero value, it will make it zero. And if it is a zero value, it will make it one. That is what this symbol, when used on a variable, does. If you are using the tilde, so the way tilde works is if you had a variable which is, let's say, an integer, that is. So if, let's say, we had int a, so this int, because of the int, a is 32 bits. So what the tilde operation will do is it will perform the not operation on all of the bit and flip the bit from 1 to 0 or 0 to 1. So you get like the inversion of all the bits in a given data type. That is what this is used for. Okay, now what all should you keep in mind? So AND operation is typically involved when you want to convert a 1 to 0, set of 1 to 0, then you would AND with zeros in the specified bit position, and then the answer would be, and 1 in every other case. If you want to retain the bits, AND it with 1. If you want to set them to 0, clearing operation, so to speak, AND it with zeros. If you want to retain the bits and change the zeros to 1, then we use the OR operation. And if you want to flip a bit from 0 to 1 or 1 to 0, then you simply XOR it with the opposite one. So if you wanted 0 to become a 1, well, simply XOR it with 1. Right? So if the bits are different, then what happens is the bit gets set. If the bits are same, then that bit is converted to 0. And that, I think I wrote it on the other side. So what I meant was if you're comparing two variables and you are doing an XOR on them, so the similar or same type of bits will be converted to 0, but opposite bits will be converted to 1. So this is like what the XOR operation gives us. What else do we have here? The right shift and the left shift. So let me just quickly run through that. Well, the left shift, given your data type and given the size of the data type and the variable, the the left shift operation will push the bits to the left, discard the bottom bits, and put zeros there. That is what happens. In case of a right shift operation, the situation, what happens depends on whether the data type is signed or unsigned. And this is very important. And again, we are talking about this with respect to the write shift. So if you have a given, let's say, char A, so A would be 1 byte. And if you're shifting bits to the right, what happens is what gets put here, what either a 0 or a 1, depends on the signedness. So if you are taking a signed data type and shifting it to the right, simply this bit will get copied over. So if this bit was 1 and you shifted it by 1, well, the value is 1. I'm assuming everything else was 0. So whatever is the bit that was available here, that is replicated. If it was 1, then it's a 1 replicated in that same position. If it's a 0, the 0 is retained and you go on moving the 0. In case of an unsigned data type, when we perform the write shift operation, uh, 0 is kind of put in the MSB location. Okay, that is like a very rapid fire overview of bit manipulation and things that you should be aware of. So, Mohammed, do you have
Yeah,
anything to
I
add?
think this pretty much covers, very concisely of what all operators are available, and maybe we can just quickly say if you want to clear, the bits, we can maybe just revisit.
Sure.
Clear the bits, then maybe AND would be the operator you would say. Uh,
Yes.
Clear AND, then maybe form a mask and then clear set, then OR
And here it's like form
form
a mask. And mask essentially means, whichever bits you
bits
wanted
on.
to clear, they should be either 1, 1, or, well, you wanted to clear them, so they should be
Zero
0 and everything else should
should
be
be
1.
one.
And then
So
this
there is
thing
a
is called
nifty
mask.
trick to form a mask, and I think it's like covered in very detailed manner, and the
Yeah,
resources we are going to provide.
right.
All right.
Cool. And well, the links to the resources will be in the description.
Yeah.
Okay, to set then use the
We have
OR operation.
then maybe if, sort of compare and then get the compare two variables or two values, then you'll use X or negate.
Yeah.
Then it's pretty simple. Negation is tilde.
Yeah, and negation of all the bits is
All the
tilde.
bits.
Negation of the sense, whether
Sense.
non-zero or 0, the variable value, that is exclamation
Exclamation.
mark.
Perfect. And then you
Okay.
have left shift and right shift operators. Right shift divides by 2, left shift multiplies by 2. So,
Right.
yeah. So,
Well, left shift divides by 2. Yes. Well, actually, left shift
like left
multiplies.
shift multiplies by 2,
Yeah.
right shift divides by 2.
Yes.
Perfect.
Perfect. So I think we pretty much at a high level gave an overview of what all bit operations people are to be aware of, and do check, these the links to the resources. Okay, perfect. Now let's talk about pointers. Again, this is a pretty deep topic, very well covered as part of the C pointers course and even the C programming languages course. What we want to talk about here is when you look at a pointer, what are the three categories that you should be able to map them to? One of the three categories. So, first category is the void type of pointer, which is just holding. Well, first off, actually, before we even go there, just to establish like a base definition, a pointer is simply a number that represents a memory address. Wow, memory address. So the way I like to think of it is you have the memory where each cell here 1 byte long. So the memory is addressable at the byte granularity. You cannot address it at a smaller or shorter granularity than that. So each byte then has an associated address with it, and a pointer variable essentially just holds this number. That's the idea, right? Now they can be of three types. At least I like to think of them as one of the three types. One is the void pointer. Other one is a pointer that has an associated data type. And the third one is the function pointer. Now, whenever we have a void pointer, so something like void star p, it simply means, hey, p is having an address, and we do not have information about what data type or you know does it is it a function pointer, is it a data pointer?
Hmm.
We do not know. It's
What
simply an
sort of
address.
data resides on that address is not known to us.
Yes, the interpretation of the data, we do not have any clue about it. We simply have the number that
Hmm.
represents the location. If we have a data type, so for example, character pointer PTR, then what we know is whatever address PTR is holding, well, we can read 1 byte from there. It is storing a character. If it was an int star PTR, for example, then we know PTR is actually, when dereferenced, if we do something like star PTR, we will read 4 bytes. Again, assuming int is a 4 byte. So, what this means is if we are having a data type pointer, then how many bytes to consume when dereferencing, that is known to the compiler.
Yeah.
The compiler can generate reads and writes based on the data type provided here.
Hmm.
Not only that, when we do something like, let's say,
Hmm.
PTR plus 1,
Hmm.
this 1 here essentially is increment by the size of the data type. So PTR, when it is, let's say, an int type of pointer, will actually go from, let's say, 0x4, if that was the initial value, to 0x8. But if it was a character pointer, then it would go from 4 to 5. This is a very important distinction. That based on the data type, the plus 1 means skip those many bytes as the data type would consume. And that is very important. And this is the case of the data type pointers.
So
Again,
basically, Piyush,
go ahead.
what I understood is void pointers, they are just numbers. We do not know what sort of data resides there when we dereference it, and hence there is no way to perform any pointer arithmetic on that because we
That is
don't know
correct.
what data
Yes.
there.
We do not know if we perform like plus and minus
Plus,
operation on it, how many bytes to move by
move forward and backward. Yeah, makes sense.
backwards. Yeah. And also at this point, uh, plus and the minus are the only operations you can perform. Arithmetic you can perform. Division and multiplication you can try.
Right.
See where that
That
goes.
makes sense actually as well. Yeah.
Yeah. And in fact, all of these are proven by hands-on demonstration again in the C pointers course. Something if you would want to, take a look at. And now the final thing is about the function pointers. So the function pointer essentially is again an address, but at that address we have instructions. So the way I like to think about dereferencing a function pointer is when we try to read from the function pointer by essentially calling it like a function, uh, what ends up happening, what you should imagine is within the CPU, the program counter is what we are essentially changing. We're asking it to go from, okay, current instruction to wherever this function pointer was pointing to, whatever address in the instruction memory the function pointer was pointing to. In fact, dereferencing a function pointer has the side effect of the program counter getting modified. So we have to ensure that function pointers are pointing to the data section. Oh, sorry, to
The
the
text.
text section. Yeah, and if they're pointing to the data, random user data, for example, then the bits would be inferred as if they are instructions, and things can go horribly wrong.
Yeah, haywire.
Just be yeah. Again, it well, a lot of things are dependent on whether you're in OS environment or bare
Right,
metal
right.
environment. But just be mindful that a function pointer essentially influences the program counter, and we expect that function pointer is pointing to code, and you have actual instructions that the CPU can
Right.
consume. So this is like a very rapid fire, I would say, overview of both these topics. Given that we have resources on the
Yeah.
site, we chose to be brief here. All right. Anything else do you think I missed?
Mm, not really. Just a little bit of motivation, because that helps me remember things. A void pointer, not much use, but you need to make sure that it still exists, because
Hmm.
functions like malloc and calloc and all return a void pointer, because they don't know what sort of data you would want to store in
Right.
that block. So
Right.
it makes
So
sense to return a void pointer there, and
right.
that
And
is why
then
we have to typically typecast. If you recall,
right.
malloc generally is preceded by a typecast operation, like
Right.
hey,
Right. So it's typically like int
int pointer,
star
and then
malloc,
malloc, yeah, some number.
something like this,
Yeah.
or usually
Hmm.
there's the classic one
Hmm.
struct
Hmm.
node star,
Right, right, right.
right? Because we do not like malloc doesn't know what you want to use the memory for, so it'll just give you an address as a void pointer. Do whatever with it.
Hmm.
Then you are free to do whatever with it.
Right. Data type pointers, I think they are self-explanatory. The motivation is really clear there.
Hmm.
But for the function pointers, I
Yes.
think the motivation there could be this. If you are aware of the ISRs or vector tables, there you would want to have a table of pointers where you can have a specific functionality done, and that functionality would mean to serve a particular type of interrupt. So for example, a UART interrupt comes, you have a certain logic there, and that is pointed to by some function. And then maybe for I2C, you have some other pointer, which is just doing the I2C handling and stuff like that. Yeah. So here the function pointers can play a very important role and provide
Right.
a nifty way to design your vector tables.
Correct. And again, if people are interested,
Hmm.
do look up the FOPS
Right, right.
structure in the Linux kernel,
Linux.
and you will find a lot of functional
Hmm.
pointers for system calls.
Yeah.
And those are, by the way, formally also called callback functions.
Hmm. Hmm.
So function pointers or callbacks are used interchangeably, the keywords.
Cool.
Perfect. Okay. Anything else do you think that we should
Not really. I think we
probably
have
mention?
covered this in a very concise manner of what the
Yes.
pointers are, what all questions one can expect, and what all should one know in order to
Yes.
sort of have a very meaningful conversation around
With
these.
anyone, right?
Anyone.
Yeah. Yeah. All right. Perfect. So with this, I think we can conclude this lecture, and then maybe move on to doing like a small project, and then conclude the section on C
Yeah.
language.
Yeah.
Perfect. All right. With this, we'll see you in the next one.